All right, Algebra 2, welcome back. Let's go ahead and do a few examples of these exponent properties, okay? We're gonna do a lot so that we know kind of the ins and outs, right? That we're prepared for whatever kind of problem we get thrown at us, okay? So first example, we have 4 squared to the third power. We did something pretty similar up there, right? So equals, oh, I don't have my pen selected, sorry. So equals, that purple might be a little too dark. Let's use a lighter color. Okay, now we finally have use for the yellow. So 4, right? And then our property says that we have a power to a power. That's just the powers multiplied. So 2 times 3. That's going to be 4 to the 6th power. And if we punch that into our calculators, what do we get? We get 4 to the, oh, sorry, just kidding. We get 4,096. So 4,096. Beautiful. All right, so we use that power to a power property. Let's do the next one. We have -4 times 2 to the 5th squared. This one looks, and then just to kind of remind you of the ones from up there, that's kind of what that one looked like. This one looks a lot like our a, b to the m. We go ahead and assign the power to both terms, okay? So we get -4 squared times 2 to the 5th squared, right? So sometimes we have to use multiple properties. -4 times -4, we know that's 16. 2 to the 5th to the 2nd power, well, we take those two powers and multiply them, so that's 2 to the 5 times 2, which is 16 times 2 to the 10th. 16 times 2 to the 10th is kind of a big deal. It's kind of a big number. Well, it's not that big, 1,024. And then when we do times 16, then we get kind of a bigger number after that. We get 16,384. All right, you can do a lot of this in your calculator. All right, but since I kind of want you to practice your properties, I want to make sure that you're showing all this work. And it won't always be, we won't always be able to just do numbers. We'll have some examples where we're dealing with the variables. All right, 2 more parts to this kind of practice. Let's do some division here. Okay, we have a fraction being raised to a power. We apply that power to each of our parts, our numerator and denominator. So 2 to the 3rd, that's good old 8. 9 to the 3rd, that is going to be, sorry, I can't do that in my head. 729, I should have known that. Sorry about that. Cool, right? So we applied that. We took our a to the b, a over b to the 3rd, not 3rd, we want to be generic here. A over b to the m, so that means that we apply that exponent to each of the numerator and denominator. Okay, one last example of this kind. Let's go ahead and do 11 to the 5th over 11 to the 8th to the -1st power. Okay, so whenever we kind of do this stuff, sometimes there's a lot going on. Like here we can do the, we have the properties that we can do are a to the m over a to the n, right? We can do that on the inside, but then we also have this one out here. So you can kind of go about this a few different ways. We can apply that exponent first. We can go ahead and distribute, or I can deal with my mess inside. Let's deal with the mess inside first. So inside, 11 to the 5th over 11 to the 8th, I can write that as 11 to the 5 minus 8 to the -1 out here. And then we have 11, 5 minus 8, that's -3 to the -1. When we multiply those two exponents, we get -3 to the times -1. That's going to be +3. And we punch that into our calculator, we get 1,331. All right, another way we could have done this, so let's kind of try it a different way. Why don't we distribute that -1 first? So another way to do it is 11 to the -5 over 11 to the -8. Okay, and then we use our division property. That's 11 to the -5 minus -8. Okay, so that becomes plus. So then 11, -5 plus 8, that's +3. And looky, we got the same thing. okay? So whatever kind of makes more sense to you, which order, then I would go ahead and do that way, okay? Sometimes it'll be easier to do it this way, and you'll kind of see in the problems we're gonna do, or sorry, the examples we'll do in the next, in this next example set down here. Sorry, I couldn't find the words, I was tongue-tied. You'll find that this is a lot nicer for the following examples than doing this, because sometimes you can't really do the inside as much as you can here. All right, enough talk, let me show you kind of what I mean. All right, so now let's apply those properties using just variables, right? We're gonna use a mixture of variables and coefficients, but for now, let's just look at variables. So our first one, what color kind of do I want? Let's go with this. For this one, we're kind of multiplying a lot of stuff together, and it's okay if you have 3, because really all you're doing is, since you're multiplying, you can add everything together. Now we can do it step by step. I can go ahead and do these first 2 together, but we know we're just adding everything. So this is going to be equal to, if I can use my pen, x to the -4 plus 6 plus 7, right? Because eventually we're just going to add them all since it's just multiplication. So then what do we get here? Well, that's going to be -4 plus 6, which is 2. And then 2 plus 7 is 9. Okay, so that's our answer. Let's try the next one. So here, notice that we can't simplify a whole lot on the inside because there's different bases, right? I wouldn't make that into a to the b to the -2 minus 3. No, right? That's not what we do here. We can only use that property when the bases are the same, when the variables are the same. So really right now, the only thing we can do is just apply this -3. So when we do that, we get a to the -2 times -3 over b to the 3 times -3. What is that going to give us? A to the 6th, right? -2 times -3 is +6 over b to the -9. Now, whenever you see simplify, there's kind of an implication, okay? So pay close attention. Whenever you see simplify, that includes no negative exponents. The instructions won't always tell you. I will always try to put the instructions if I kind of make the problems or if I put it on our checkpoint, but sometimes it'll just say simplify, and there's kind of the hidden implication that you don't want any negative exponents to remain. Okay, and that you can see here, we have a negative exponent there. So let's take care of it. Well, our rule from above, it was 1 over a to the, sorry, just kidding. It was a to the -m is equal to 1 over a to the m. Well, how do we deal with it when it's already in the denominator? Well, notice the kind of terminology I used above. All we have to do is get rid of the negative and flip. Same thing here. All we do is get rid of the negative and flip. Technically, this has already been flipped, so I just trade places to the numerator. So this is equal to a to the 6 times b to the +9. I take the negative away and I throw it to the other side of our fraction symbol. Okay, I know that's kind of like, it feels a little cheap, right? Just kind of a little procedure, just throw it to the top. That's kind of how that works, right? So if I had it backwards, if I had a to the 6, b to the -9, then what I would do is just take my a to the 6 stays the same, and then remember this is technically over 1. I change that to a +9 and I throw it to the bottom. Okay, so that's kind of what happened. Sorry, the arrow should be on that one. That is what happened there. All right, hopefully that sounds okay. We'll see a few more examples of that. All right, so now let's kind of get a little bit grosser. All right, so part C, what's going on here, we have both variables and coefficients. So really, we should be multiplying our like terms together. So we have 7 times 10. All right, let's group those together. And then y squared times negative y to the -4th. So let's group those together. And then z to the 5th times z to the -1, right? You don't always see this little dot for the multiplication symbol. Sometimes you'll just see the variables placed together. That's okay. It means the same thing, all right? So now let's do each piece together, or let's do each piece individually, sorry. 7 times 10 is 70. Y squared times y to the negative fourth, that's going to be y. 2 plus negative 4, that's to the negative 2. Z to the 5 plus negative 1, that's positive 4. Okay, no negative exponents, so I need to take this y to the negative 2. This is technically over 1. Y to the negative 2, make the exponent positive and toss it below. Okay, it's negative because it doesn't like where it is. It wants to be on the other side of the fraction bar. Okay, if that kind of helps you. It's negative, it doesn't like where it is. Let's throw it to somewhere where it will like to be. Now it's positive, now it's happy. Okay, 2 more examples. Let's try this one here, part D. All right, so let's start with our numerator with going ahead and distributing the square. And the reason why is because if that is there, that's trapped by the exponent. I can't do my division properties yet. I can't do the, that we could say is negative 3 minus 5, but I can't do that because it's trapped by the square. Okay, so let's apply that squared first. What's it going to give us? X to the negative 6, y to the positive 6, over x to the 5th, y to the 6. Okay, now we're in business. Now we can go ahead and apply our division properties. Okay, so x to the negative 6 minus 5. Now for the y's, let's kind of work smartly here. Y to the 6 divided by y to the 6. Well, that just simplifies out, right? That just goes to 1. But if you need confirmation that it does, well, if I use my properties, that's just y to the 6 minus 6. And then y to the 6 minus 6 is y to the 0. And what's y to the 0? 1, right? Because anything to the 0 is 1 except for 0. All right, so that kind of confirms that that's going to simplify itself out. Okay, so then negative 6 minus 5, that's equal to negative 11. And then no negative exponents. It wants to be happy on the other side of the fraction bar. We get 1 over x to the 11. Awesome. One more example, and then we'll go into a little bit of scientific notation, okay? These videos might be a little bit longer, but that's okay. Let's go ahead and do this one. Now we can go ahead and clean up a little bit inside first, but why don't we just directly apply this negative 3 to everything, okay? You'll see that it's a little bit nicer to deal with that way. 2 to the negative 3, c to the negative 12, d, negative 2 times 3, negative 3, that's positive 6, divided by 3 to the negative 3, c to the negative 9, d to the negative 18. Okay, so this is kind of scary, but we can do it. All right, let's go ahead and do our, let's do the pieces individually. So let's deal with 2 to the negative 3 over 3 to the negative 3 alone. And now for this one, that's c to the negative 12 minus negative 9. This one is d to the 6 minus negative 18. All right, so now let's deal with this. All right, so no negative exponents. So let's throw it to the other side to make them happy, to make them positive. So I got to throw this to the numerator to get 3 to the positive 3. And I go to throw this to the denominator to get 2 to the positive 3. All right, so notice kind of the changes that happened there. And then this piece, negative 12 plus 9, that's going to be c to the third power. Now, when you're doing this stuff right here, you guys, this is technically all in the numerator because this is all over 1, this is all over 1. Okay, so kind of pay close attention to that. And I already made a mistake here because negative 12 minus negative 9, that's not positive 3, that's negative 3. So we have c to the negative 3 in our numerator times d to the, that's 6 plus 18. So we get 24. All right, so really what we have is 3 cubed, we know that's 27, c to the negative 3, d to the 24, over 2 cubed, that's 8. We're not quite done, we have one more thing left to do. We got to make our c to the negative 3 happy. Throw it to the other side of the fraction bar. d24 over 8 to the c to the positive 3, okay? That was kind of a doozy, all right? But kind of expect to get something this kind of convoluted, right? I want you to be able to be fluent in applying these properties. And you very well could have done c to the 4 minus 3, d to the negative 2 minus 6, simplify that a little bit, and then apply the negative 3. Either way would have worked, right? For me, this one's a little bit easier. For you, it might be the other way. So why don't you give that a shot if you want to see if that's a little bit easier for you, okay? All right, kind of a long video, but that's okay. We'll cover scientific notation in the next one, in the next part of this lesson. So meet me there, okay? We're almost done.